Hello, so today we are going to continue on problems from weekly contest 401. The third problem is maximum total reward using operations, problem 1. So basically with this problem we have an array of reward values, right, of length n that represents the values of some rewards, and we start out with an initial total reward with a value of 0. And then initially all the indices of rewards values are unmarked. And our goal is to mark these, but in a way to get a maximum total reward. But how do we do that? Well, there is an operation we can do any number of times, and that operation is described here, which is basically we choose an index from this reward value, and if the value at that index is greater than the current total reward so far, then we add the value of that reward to our total reward value and then mark the index. So just to simplify it a little bit, we start out with a total reward. We have an array of that we can pick from and mark an index, but we will be able to bank the reward value, which is added to our total reward, only if the value at that position is greater than our current total reward. So if our current total reward is 3 and the value is 6, then we can add that value. So now we have 9 total reward. If the value is, let's say, 2 and our total reward is 3, we won't add it. We can't add it and mark the element. Okay, so we need to be smart about how we choose the element in which order. So let's take a look at this first example. This is the first array. This is the reward values array. So what we can do is, first we choose this one. So now our total reward value is 1. Now we can't, if we choose this one, we can't use it because its value is not greater than our current total, which is 1, right? And so 3 we can, because 3 is bigger than 1. So when we do that, now we have 4. But now that we have 4, we can't pick this one because the value is smaller. And so this is our final and optimal number. For this one, it's better to first take 1. So now our total reward is 1. And then we take 4 because 4 is bigger than 1. And so now our total reward is 5. And now we can take 6. We can't take 3 or 2 because they are smaller, but we can take 6. And if we take 6, now the total reward is 11 because 6 is bigger than 5. So that's our best one. You could try other combinations, but they will all be smaller than 11. So that's the idea. Now let's see how we can tackle it. Okay, so let's see how we can tackle this. Well, the first thing to notice is that we definitely want to take the elements in order, because if we take them like out of order, let's say if we take the biggest first, like this one here, if we take the biggest element first, then we will quickly just be in a bad situation. So for example, let's say we take the biggest one first, x. So if we take x first, then immediately let's call this take, then immediately our reward is 6. We can't take any other element, and that's not the optimal solution, of course. So that tells you we definitely need to do some sort of sorting. So we need to sort, but let's try it. So if we sort, we get this, but we know we can't just go in order, right? Because let's say if we just go in order and just pick in the order of the elements. So if we take x equal to 1 first, so we take this one. We can still take 2, right? Because 2 is bigger than 1, so we take 2. Now our total reward x is 3. Now we can take this one, so we take this one. We can take 4 because it's bigger, so now we have 7. But now we can't take the 6, so now we are stuck. This is not the optimal answer. So this basically tells us we can't just go in sorted order. Okay, so it's very tricky. Even if you try other combinations, it's very tricky to just have a heuristic to use. So in that case, we should either try all of them or find a clever way. So try all of them, maybe. Now another idea, if you look at this, is, okay, what if we reverse it? What if we sort of start from the biggest value and just go and just see what would have made sense to the left. But that's getting really complicated. So a different approach is, let's just go and try all of them. So first we said we will sort the rewards values. So we'll just sort our rewards values. Okay, let's call this. Okay, so we do this first. Now, once we do that, what should we do? Well, let's try something here. Let's take this value and we can just go through them one by one. Okay, now each time let's keep track of something let's call it the candidates, which basically means this is the candidates for the rewards value. Okay, let's just have this as a unique set. Start with 0 if we don't pick anything. So this is basically, let's have this be the candidates for total rewards value. Now, if we are able to sort of have all the possible candidates, then at the end we can just return max of candidates, right? So in our process here, what we can do is, in the second step, we can just get all candidates, okay, possible for total reward, and pick the max. Now, get the max, pick the max, right? That would be the optimal one. Now, the tricky part is how to do this one. So let's think about how we can do it. What would be the process for doing this one, okay? So, well, if we just go through, let's call this the rewards values, just shorten it a little bit, call it R. If we go through it, what can we do? Well, we definitely know that that just picking the element by itself, that's a candidate. That's a possible approach. Is if we can just pick 2, right, and do just one operation, right? We can just pick 6. It's not the optimal one, but it's definitely an answer. So we definitely let's for each value, let's see the candidates that value can be part of, right? So we know that definitely just picking that element is a possible candidate. So we can just add that to the list of possible candidates here. Okay. But also if we go through, let's say if you are doing like this, and you pick 1, if we pick, our R is 1 and we pick 1, well, we know we have a choice. We could pick 2, we could pick 3, we could pick 4, we could pick 6, because all of them are bigger. We could pick one of them, definitely. From 1, we could pick any one of them. Now, if we are at 6, right? If we are at 4, for example, if we are at the element 4, and we have already explored 1, 2, 3, well, all the previous candidates, what are all the previous candidates that we can have? Well, we could have maybe just picked 1, only 1, and now we can pick 4, or we could have picked 1 and 2, so the total reward is 3 in that case, right? The total reward in that case is 3, which is from 1 plus 2. Or we could have picked maybe 1 and 3, so that's 4. That's from picking 1 and 3. That's a possible approach. We could have picked can we pick 1, 2, and 3? Well, if we pick 1 and pick 2, now we have 3, we can't pick 3, so that's not possible. We could just pick 4, right? Just pick 4 itself, right? So these are all the candidates before, if we are only including before 4. So these are all the possibilities before, before 4, before this value 4. And so now if we have these candidates, we can just go through each of them and see if we can pick 4, then we have a new candidates. So if we can pick, can we pick 4 with 1? Yes. So let's add that to the list of our, so new candidates. Let's add that to the list. So if we can pick, for 1, we can pick 4. So now it's going to be 5, which is 1 plus 4. Okay. For 3, we can pick 4 because 4 is greater. So in that case, we have 7, right? 7 from 3 plus 4. Okay. Can we pick 4 here? We can't. Can we pick it for this one? No, because it's not greater. So these are the new candidates, but now after this iteration, right, our list of updated candidates should be the combination of both, because both are possible. So it's going to be this and this, right? Okay. So that's the core idea here, is that for each element in the word value, let's keep track of all the previous candidates and see if we can add this element into each one of them. If we can, that's a new possible candidate. But for each one, we need to keep the previous one, because we could have stopped at just picking 1. We could have stopped at just picking 1 and 2. That's definitely an option, right? So that's exactly what we are going to do here, which means since we'll end up, which means here, we will need to just go through the list of candidates, right? That's exactly what I did for 4. I just went through all the existing candidates and checked if we can add 4 into each one of them. So that's exactly what we do here. And then we check, is it possible to add the current value? Now, it's only possible if the value is bigger than the current candidates, right? Now, if that's possible, then we have a new candidate value, which is going to be just adding the reward value, right? And then now our updated candidates, what should that be? It should be just the existing candidates plus the new candidates, right? So our candidates is going to be, the new updated one is going to be just that plus this. Okay? And that's pretty much it. So now it's pretty easy. So you had to sort of, I know it's tricky to imagine, but you would get to used to it. You had to sort of fast forward and say, okay, what if I have all the candidates for some elements? How can I use that? And then from there, you can just construct your solution, okay? And that's the idea pretty much that we are going to go from. So here, it's good. What we are doing is basically, for each word, collect all possible candidates, including the value, okay? And then updates the list of candidates with those values, right? Okay, so that's the pretty much the algorithm that we will use. So let's just pick this up. It's going to be like that. Go here. This. Don't need this. I don't need this piece here, and we can go like that. Okay. And then like this, and then we go like that. Okay. Can run this. This needs to be reward values, of course. And this, of course, set to do that. You need some sort of union, but you could do union like this. Actually, instead of doing union, I want to do something else. We can just initialize this to the first list, right? And then this new candidates will have everything. So we can just, it's amount to the same thing. It amounts to the same thing as adding them together. So we copy the candidates. We have the initial, oh, sorry, I forgot to sort. We need to sort so that it's in order. Okay, cool. And now we can submit. And this gets accepted. Okay, so that's pretty much it. Sort and then try all the possibilities pretty much. That's pretty much it. Thanks for watching and see you on the next one. Bye.